Okay, hi, this is John Marsh. This is NCS 210 in the fall of 2013, and I'm here to do a couple of example problems for Forouzan. I'm going to try to do several of them in this video, starting with 3.4, which was on your first homework assignment. 3.4 says, what is the bandwidth of a signal that can be decomposed into 5 sine waves with frequencies 0, 20, 50, 100, and 200 hertz? All peak amplitudes are the same. Draw the bandwidth. And they want the bandwidth of the signal. And so, given a signal with 5 sine waves in the decomposed version. I don't know how to write that. 0, 20, 50, 100, and 200 hertz. All with equal amplitudes. Well, so calculate the bandwidth and draw the spectrum. Okay, well, I'm going to go ahead and just start with the drawing. 0, 20, and a little bit more than twice that is 50, and then twice 50 is 100, and twice 100 is 200. And this is frequency in hertz, because these are all given in hertz. And I'm going to draw my spectrum by drawing sort of spikes at these frequencies, all of equal height. And 200. There we go. And the bandwidth is the high frequency minus the low frequency, when there's a bunch of frequencies that go into something like this. And the highest one is 200, the lowest one is 0. And so the bandwidth is 200 hertz here. Okay? And you can say that this is the bandwidth, just drawing on the number line like that. Okay, so that's problem 4. And now I'm also going to do 6 and 13 on the same page here, in the same video. 3.6 says, which has a higher bandwidth? Sine wave with f equals 100 hertz, or a sine wave with f equals 200 hertz. Okay, this is almost a trick question, because when we have a single sine wave, or a cosine wave for that matter, we have a single frequency. Okay, and so in either of these cases, 100 hertz or 200 hertz, a single frequency means that we have a bandwidth of 0. Okay, and so neither, the answer is neither. They both have bandwidth equal to 0. Okay, finally, in problem 313, I'm going to show you the problem statement in the book. A non-periodic composite, get this in here, a non-periodic composite signal contains frequencies from 10 to 30 kilohertz. The peak amplitude is 10 volts for the lowest and highest signals, and is 30 volts for the 20 kilohertz signal. Assuming that the amplitudes change gradually from the minimum to the maximum, draw the frequency spectrum. So it's 10 volts high for the lowest and highest frequency signals. So it's 10 at 10 and 30, and then it goes up to 30 at 20. So I can draw that. Okay. So how do I write this? Non-periodic composite signal. Non-periodic. Amplitude 10 volts at 10 and 30 kilohertz. And also it is 30 volts at 20 kilohertz. In other words, from 10 to 20 it goes up, and then it comes back down when we get to 30. So the spectrum looks something like this. If this is 10 kilohertz, I'm going to label my axis with kilohertz here. Ooh, sorry. All crooked on you here. Then this is 20 and this is 30, and I can label this voltage as a function of frequency, and so this is the frequency with units kilohertz. And I'm going to write 10 volts, 20 volts, 30 volts, and at 10 and 30 kilohertz it is 10 volts, and at 20 kilohertz it's all the way up at 30 volts. And so I can make this spectrum like this, and I can fill in that picture like this. So this spectrum is concentrated between 10 and 30, and it has a shape like this. Okay, hope that helps on homework 1. Thanks for listening.